So in the last video, we talked about functions. We've talked about linear functions before. For the rest of the semester, everything that we're going to look at is going to be a different type of function and how we can use those functions. So the next type of function that we're going to look at are polynomial functions, and in particular, quadratic functions. So before we get into the specifics, let's start with what is a polynomial function. So I'm going to write down a definition here, and then I'm going to explain it. Okay. Polynomial function is written in the following form. We still use f of x. It's a function. A sub n x to the n power plus a sub n minus 1, and then x to the n minus 1 power. And this just continues until we get to a sub 2x squared, then a sub 1x, and then x to the first, and then finally plus a sub 0, x to the 0. Sorry for running out of room there. Okay, so this just keeps going until you get down to x to the 0 power. And keep in mind that x to the 0 is just 1, okay? A0, A1, A2, all the way to A sub n are real numbers. And a sub n can't be 0. Okay, so this first coefficient here, it can't be 0. Okay, these coefficients, that's because then this term wouldn't count. 0 times anything, it doesn't matter what the power of x is, 0 times anything is 0. So we're saying if this is our polynomial, this first coefficient can't be 0, because then this would really be a sub n. Okay, this would be our first coefficient. N is a non-negative integer. This is really saying that your powers are all positive. Okay. And then this is a side note, and we're going to be working with this a tremendous amount over the next few videos. A polynomial function is identified by its degree. The degree is the highest power of x. Okay, it's really this n right here. That would be the degree. So let me give you an example of a polynomial so that you can really see how this works. So if we had f of x is equal to 3x to the 4th plus 8x cubed minus 7x squared plus 2x minus 4. This is a polynomial. The degree of this polynomial is the highest power of x. So the degree is 4. Okay. The 3, the 8, the -7, the 2, and the -4, These are our coefficients of our x. Okay, that's our A0, A1, A2, AN. And the subscripts just tell you that these are different, that the coefficients are different numbers. Okay, if we just said A, then we would be indicating that every coefficient is the same, and it's not. You see here, this is 3, this is 8. They're different. Okay, the powers, they go down by 1. So we start with 4, then we have 4, 3, 2, 1, 0. This is in standard form, okay? We could do a different polynomial. We have f of x equals negative 5x to the 7th plus 2x to the 5th minus 7x squared plus 1. Okay, this is a polynomial. Okay, every term, so our terms are divided by plus or minus signs. Every term has a coefficient, it has a value, it has a variable, and it has an integral power. Okay, so this is a term. We say integral because these have to be integers. Okay, so these have terms. The degree here is 7. That's the highest power of x. Now what you'll also notice is that in the first one, the powers go down by 1. In the second one, they don't, right? They start at 7, but then you're skipping a lot. The reason why you're skipping those is because those coefficients are 0. So these coefficients over here could be 0. It's just the first one that can't be 0, because then your degree changes, right? If this had been a 0, then your degree would just be a 5. So in standard form, this is not that important right now. It will become very important. Not in the next video, but the video after that when we're doing division, okay? So in standard form, what we would do is we would put in placeholders. So it would become negative 5x to the 7th, and because there is no x to the 6th, we put in a 0 as the coefficient. So 0x to the 6th, and you can either add that or you could subtract it because it's 0, so it makes no difference. Then we have our plus 2x to the 5th. We're missing an x to the 4th, so again, we put in a placeholder. We're missing x to the 3rd, so again, we put in a placeholder. Then we have our minus 7x squared. We're missing x to the 1st, so we put in a placeholder. Remember, if there is no exponent, then it's a 1. And then plus 1, and that's really plus 1 times x to the 0. Okay, so you would not write it in standard form except for division. Okay, you would not write this in standard form. This is long. There's no reason for these placeholders. You would write it as the negative 5x to the 5th, to the 7th plus 2x to the 5th minus 7x squared plus 1. Okay, let's do one more. Let's say that we have f of x equals 3x to the 5th minus 2. So this is also a polynomial, okay? We have more than one term. As long as we have more than one term, it's a polynomial, right? So it's poly. So we have more than one term. If it had one term, we would call it a monomial. This is a polynomial. We just don't have a lot of terms in the middle. That's fine. So the degree, we look at the highest power of x. Highest power of x is 5. And if we put this in standard form, all we're saying is that we're including those placeholders. So our f of x is going to equal 3x to the 5th. There is no x to the 4th, so we just put a 0 as the coefficient. Same thing with x to the third. Same thing with x squared. Same thing with x to the first. And then we have a minus 2. And if this had been a minus 2x, then you would have done minus 2x plus 0. Okay, so you would still have, for that x to the 0, for this very last term, you would still have a placeholder. Okay, so this is a polynomial function. It consists of more than one term. Okay, so even a linear function is a polynomial function. There are two terms there. If we have 3x plus 2, our degree is 1. Okay, we could have a polynomial with a degree of 1. That's fine. A quadratic is a polynomial of degree 2. And polynomials with different degrees, they behave differently. Their graphs look very similar. Okay, so all polynomials with a degree of 2 look very similar. All polynomials with a degree of 3 will look similar. Same thing with the degree of 4 and so forth. If they have the same degree, they all have a very similar shape. So for a quadratic, the shape is a parabola. And it's in the form f of x is equal to ax squared plus bx plus c. Okay, a, b, and c are integers. And we'll see why this is true a little bit later in our videos, okay, a little bit later in the semester. But if a is greater than 0, the parabola faces up. I'm going to say opens up. What does this mean? It means that the shape of our graph is going to look like this. And if a is less than 0, then the parabola is going to open down. So a parabola is similar to a U, but we discussed this when we were looking at domain. These ends just keep coming out. They don't go straight up, right? It wouldn't be a function if they went straight up in a vertical line. They keep going out, just slowly, okay? Okay, so now let's talk about solving a quadratic, okay? So, well, even before that, let's talk about what we mean by it is solving. Let's talk about what we mean when we talk about solutions to a quadratic, okay? When we solve it, what we're doing is we're saying that we're finding something called the roots. So the roots are the same thing as the x-intercepts, which are the same thing as the zeros. All of these things are almost interchangeable, almost. I'll explain in a second. So the solution to a quadratic, And I'll put this in a different color because it's actually really important. Okay, the solution to a quadratic equation consists of the roots. So we call them typically roots. You'll hear that word a lot. Or zeros. Okay. If the parabola crosses the x-axis the roots are the x-intercepts. So it's wherever, it's the x values where you cross the x-axis, okay, wherever you hit the x-axis. Now this is the difference. So we could call them the x-intercepts if it passes through the x-axis on a graph. Otherwise, the roots are going to be imaginary. Okay, so every parabola, every quadratic equation has roots, okay? And those roots are the x-intercepts. If this is a parabola that crosses the x-axis, you have some parabolas where it doesn't. So let's just take the three different instances, okay? The three different types of graphs. All of these are going to be graphs that face up, but you can do exactly the same thing if the graphs face down. So you have three possibilities. The first possibility, I'm going to just draw these three axes together. Sorry about that Y. It's not coming out on the paper. Okay, but these are the Y's. It's the Y-axis. Okay. Okay, so here are the three different possibilities. The first possibility is we have a parabola that crosses the x-axis twice. These would be the roots. So notice it's the x-intercept. The second possibility is you have a parabola that crosses the x-axis just once. These are arrows. Again, it's not coming out on the page very well, but those are just arrows. Okay. That's where the vertex is on the x-axis. Okay, and what we're saying is there's only one real root. And then the very last instance is where you have a parabola which sits entirely above the x-axis. Okay, and in this case, if you notice, there are no x-intercepts, right? It never crosses the x-axis. So this has two imaginary roots. Okay, now if you're asking yourself with the one real root, can you have one real and one imaginary? No, this is just a repeated root, okay? Okay, so let's talk about how to actually solve these. So we can solve it in 3 different ways. The first way is through factoring. We can use something called the quadratic formula, which some of you might already be familiar with. And we can solve through completing the square. So this video is going to cover factoring and it's going to cover the quadratic formula. Completing the square will be in the next video. Okay. So we're just going to practice factoring. I'm going to give you a bunch of different quadratics, and we're going to go through and we're going to factor them. This is the type of thing where knowing your number facts is really important. Number facts would be multiplication tables, okay? Number facts would also be just what kinds of numbers, what do these numbers add up to? What are the numbers that add up to 10? You know, we've got 5 and 5, we've got 6 and 4, 7 and 3, 8 and 2. Those would all be what we would call number facts. If you know those really well, this is not going to be a complex thing for you. If you don't, there's a little bit of trial and error, and feel free to use a calculator at any time. I don't want you getting bogged down in the numbers, but if you don't know those multiplication tables well, I do encourage you to go back and really learn them because they'll help you a tremendous amount here. Okay, so let's take some quadratics. We're going to start where a is equal to 1, okay? Meaning that when we have f of x equals ax squared plus bx plus c, the first coefficient is 1, so it's just going to look like x squared, okay? So let's take x squared minus 4x minus 21. And this one I'm going to show a lot more work under because I'm going to explain the factoring process, okay? So what we're doing is we're trying to figure out 2 numbers that add to b and multiply to c. And once we factor this, I'm going to show you why that's the case, okay? So they're going to add to b and multiply to c. Once we factor this, again, I'll show you why this is the case, okay? Multiply 2c. Okay, so in other words, in this case, we're looking for 2 numbers that are multiplying to negative 21 and adding to negative 4. Now, if you're not sure how to approach this, the best thing to do is to look for factors of negative 21 first. Then you're going to determine which pairs add to negative 4. Okay, the reason for that is that there are actually an infinite number of pairs of numbers that will add to negative 4. There are only very few that multiply to negative 21. Okay, in fact, there are only 2 pairs that multiply to negative 21. You're either getting a 7 and a 3, or you're getting a 1 and a 21. And one factor is negative, We know that one factor is negative because they have to multiply to a negative 21. If they were both positive, it would be a positive 21. If they were both negative, it would also be a positive 21. So these are the only possibilities. So what we're doing is we're saying, can we get negative 4 from any of these possibilities? And the answer is yes, right? From the 7 and 3. 1 and 21, if you add them together, I don't care which is negative, there's no way that you're going to get a 4, okay? But 7 and 3 you can. And 7 and 3 actually, in order to get a negative number, the larger number has to be negative, right? If you have a negative b, then your larger factor has to be negative. So our answer here is a negative 7 and a 3. Okay, so just a note, if b is negative, the larger factor has to be negative. You can figure that out. But again, this is like, okay, well, I don't have to try as many possibilities, okay? Because then you don't have to try both negative 7 and 3 and 7 and negative 3, right? For every one of these pairs, there are 2 possibilities. Either the first number is negative or the second number is negative. So this saves you a little bit of time. I'm going to say the larger factor. And vice versa. If b is positive, the larger factor is going to be positive. This is when c is negative. When c is positive, then it's easy because they both have the same sign, okay? Okay, so what does this mean? How do we put this in then? That means x squared minus 4x minus 21 is equal to, in factored form, x minus 7 times x plus 3. Okay, so this is the factored form. If it just says to factor, you're done. You don't have to solve. You don't have to go any further. Okay. If you're asked to find the roots, then you need to solve this. So when you're asked to find the roots of any polynomial, set it equal to 0. The reason why you're setting it equal to 0, remember, is that you're trying to figure out what the x-intercepts are. The x-intercepts are when y equals 0. That's why you're setting it equal to 0. Okay, remember this is like y equals x squared minus 4x minus 21. So you set it equal to 0 and solve for x. So let's do that. X minus 7 times x plus 3 is equal to 0. And what we could do to solve this is a simple solve, because what we're going to use is the 0 property of multiplication, which says anything times 0 is 0. So that means if x minus 7 is 0, this whole thing is 0, because 0 times x plus 3 is 0. If x plus 3 is 0, then again, the whole thing is 0 because 0 times x minus 7 is 0. So it doesn't matter if x minus 7 gives you a number because we already know that x plus 3 is 0. Okay, so 0 times anything is 0. So that's what we're going to use. And we're going to say, okay, this means either x minus 7 has to equal 0 or x plus 3 has to equal 0. And if we solve this for x, these are two really simple linear equations. We add 7 to both sides. Here on this side, we could subtract 3 from both sides. And we get our roots. X equals 7 and x equals 3. Okay, so we're using the zero property of multiplication. Okay, zero property of multiplication, which says 0 times anything is equal to 0. That's what we use in order to solve. Okay, so we get our roots. X equals 7 and x equals 3. This is our final answer then. And what you'll see is that finding the roots by factoring is the easiest way to find the roots. It's the fastest, okay? But that's going to depend a little bit on you, because if you don't know your number facts very well, and there are a lot of factors, this may take you a very long time. There's no fast way of doing it, okay? Okay. We're just going to go through a bunch of examples now. We're going to continue with a is equal to 1 for a few more. And then we're going to look at, okay, well, what happens when a is equal to 2? So let's go to our next one. So in this one, we have x squared minus 4x minus 45. Okay. Well, that means, so your a is 1, your b is negative 4, and your c is negative 45. Notice that they can be negative, that's fine. We're taking the sign that comes directly before them. That's how we know that these are negative. So we're looking for two numbers that multiply to negative 45 and two numbers that add to negative 4. And negative 45 has a few factors. The factors of negative 45 are 45 and 1. So notice I leave out the negative signs because I can put those in later. We have 45 and 1. We have 15 and 3. And we have 9 and 5. So we have to look at each of these pairs and say which one of them, when we add them together or subtract them, can give us 4, okay, or negative 4. So 45 and 1, there's no way. 45 plus 1, 45 minus 1, negative 1 plus 45, that's not going to give it. 15 and 3, also, they're 11 apart. There's no way. But 9 and 5 will. Now, if you notice, our C is negative. So now in order to figure out what we need to do, we're going to look at the B. The B is negative. So the greater factor is going to be negative. So we have negative 9 and positive 5. Okay, and you should just double check that they actually do work here. Okay. So what does that mean? That means that our factors are x minus 9 and x plus 5. We're going to set it equal to 0 because we're going to solve for the roots. So we have x minus 9 is equal to 0, and x plus 5 is equal to 0, right? If either one of these is 0, the whole thing is 0. So on the left, we can add 9 to both sides. On the right, we can subtract 5 from both sides. And we get our two roots. Our roots are x equals positive 9. Notice our roots are just the opposite of what you see in here, right? This was a negative 9 because you're adding 9 to both sides. Your root winds up as a positive 9. And here your root winds up as a negative 5. So these are our roots. Again, sometimes you'll hear these called zeros. You will not always hear them called x-intercepts because we haven't seen this yet, but there will be some quadratics that don't have x-intercepts, okay? So here, these are both, this says that this is going to cross the x-axis when x is equal to 9 and x is equal to negative 5. That means that the points 9, 0 and negative 5, 0 are on this graph. Let's take another one. X squared plus 11x minus 60. So once again, two numbers. Our A is 1, our B is 11, and our C is negative 60. So we need two numbers that multiply to negative 60 and add to 11. Again, we're going to look at the factors of negative 60. And some of you, you don't need to write down the factors. Some of you are going to know right away what the numbers are. So factors of negative 60, factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4, 4 and 15, 5 and 12, 6 and 10, and that's it. Okay, so here's a case where we have many pairs. So this is a case where knowing your number facts can be really helpful. Some of them we can eliminate almost immediately because we know they have to be the two numbers. You have to be able to get them 11 apart. Okay, so 1 and 60 clearly doesn't. 2 and 30 clearly doesn't. 3 and 20 doesn't. The rest of them, I could see them being problems where you're like, I'm not 100% sure. So add and subtract. If you add 4 and 15, you get 19, but if you subtract, you get 11. So this works. Let's just double check the others. 5 and 12 gives you 17, but 12 minus 5 gives you 7. This can't work. 6 and 10 is 16, 10 minus 6 is 4, can't work. Notice I'm doing that. If I were to get you could get a negative number 2, that doesn't matter. But you should, if you can't get the 11 by adding or subtracting, then don't even bother. Okay, so 15 and 4 is the only one that works. We need positive 11. So the larger factor has to be positive. So this is going to be a 15 and a negative 4. And again, if that type of stuff confuses you, just plug it in and see if it works. Okay? You don't have to worry about knowing this. This can just be helpful. Again, just in terms of number of facts. If your B is positive, then in order to get a positive number, when you have a negative number, you have to start off with positive on the positive side, where your larger number is positive. Okay? So what does this mean? This means that our factors are x plus 15, x minus 4. That's equal to 0 if we're finding the roots. So either x plus 15 equals 0 or x minus 4 is equal to 0. We can see that that's going to give us roots of x equals negative 15 and x equals positive 4. That's where it's going to cross the x-axis. Okay. Let's take one more with an a equal to 1. So x x squared minus x minus 30. So again, it's good to identify your a, b, and c. Here, it's not, the a isn't important because our a is 1. Our b is -1. Our c is -30. Okay, so what does this mean? We need two numbers that multiply to -30 and two numbers that add to -1. So factors of 30. This one there aren't too many. We have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. So 1 and 30 are now 1 away. 2 and 15 are not 1 away. 3 and 10 are not 1 away. 5 and 6 are. Our b is negative, so the larger number is negative. So -6 and +5. Okay, so what does this mean? This means our factors are x minus 6 times x plus 5. We set it equal to 0. Either x minus 6 equals 0 or x plus 5 equals 0. Which means our roots, when we solve those equations, are x equals 6 and x equals -5. Okay, so this is what you do when a is equal to 1. Now, if a is equal to something other than 1, so 2, 5, 10, 15, 20, the process is always the same. So let's go through that process and then we'll do a few examples. Okay, and we're going to go through the process using an example. So the first example is 2x squared plus 11x minus 21. Okay. So you're going to identify your a, b, and c. So here, our a is 2, our b is 11, and our c is -21. Then you're going to multiply a times c. Okay, so a times c here is 2 times -21. That's -42. Okay. The next thing that you're going to do is you're going to come up with two numbers. This is the same thing as before. Instead of multiplying to c, they're going to multiply to a times c. Okay. And two numbers that add to b. So we have two numbers that should multiply to -42, and they should add to 11. So let's find those two numbers. We're going to look for the multiples of -42. So we have 1 and 42. We have 2 and 21, 3 and 14, and 6 and 7. Okay. Now they need to be 11 apart, right? So 1 and 42 doesn't work. 2 and 21 don't work. 6 and 7 don't work. 3 and 14 are the one that we want. And our b is positive. This is negative, so we need the larger number to be positive. So our numbers are going to be 14 and -3. So one of them has to be negative. Okay. Which means So here's the next step. The next step is that you're going to replace your bx with what you found in part 3. So here's what that means. That means that this is now, instead of 2x squared plus 11x minus 21, since we could get the 11 by doing 14 plus negative 3, we're going to replace this 11x. So it's going to become 2x squared plus 14x minus 3x minus 21. Okay, so you see that we took this 11x here, and we just switched it out with the 14x minus 3x. The order in which you do it doesn't matter. So if you had written negative 3x plus 14x, that would be absolutely fine. Okay, it'll look a little bit different, but in your last step, it will wind up looking the same. And I'll show you how. So the order of the numbers doesn't matter. Okay. And then your last step is to do something called factor by grouping. So all you're going to do is you're going to split your polynomial into 2 pairs, okay? 2 terms. So you're going to group the terms in pairs. So you have 2x squared plus 14x. And you have negative 3x minus 21. Then you're going to factor out I'm going to change the way I say this because otherwise it's not going to make sense. You're going to pull out a common factor from each pair. So from the 2x squared plus 14x, they both have an x in common. They also both have a 2 in common. We could pull out a 2x. And what we're left with is x plus 7. Okay. Then, from the second pair, we have negative 3x minus 21. They both have a negative 3 in common. So pull out the negative from the second pair if you can. Okay. So this is going to be plus negative 3, again, times x plus 7. These are always going to be the same. If they're not the same, you made a mistake. Okay? So these will always be the same. Your last step is going to be to pull out the common expression that remains. So it's still a common factor, but now it's not a single number or a single number and variable. Now it's an expression. So both of these have an x minus 7. So what you're doing is you're factoring out the x minus 7 and you're moving it to the front. So we're taking this x plus 7, we're pulling it out to the front, and in the first term, the only thing that's left is the 2x. And in the second term, a negative 3 is left. So it becomes x plus 7 times 2x minus 3. Okay, if we were to redistribute this x plus 7 in, then we would get x plus 7 times 2x, and then x plus 7 times negative 3, which is what we have here. Okay, and this is fully factored. So now we can solve for the roots. And we solve for the roots in the same way. So you set each factor equal to 0. This one is going to give us x equals negative 7. This second one I'll work through with you. You add 3 to both sides. So we get 2x plus 2x is equal to 3. Then you would divide both sides by 2. Okay, and you get that your roots are x equals negative 7 and x equals 3 halves. Those are your roots. Okay, so again, we multiplied our a and our c. Then we did exactly what we did in all of the previous problems, except instead of the numbers multiplying to c, they're multiplying to a times c. Then we took this middle term, this 11x or bx term, and we replaced it with this 14x minus 3x. And then we did factor by grouping. So to factor by grouping, we took the 2x, we took a common factor out of each of the pairs. So we took a 2x out of the 14x and a 2x out of the 2x squared. Got 2x times x plus 7. Then we took a negative 3 out of the second pair, and we got an x plus 7. Then we have x plus 7 times 2x minus 3. The 2x's remain, and the minus 3 remains. Okay? Now we could have rearranged this in a different way. So I'm going to put this just off to the side, just so that you see that it works if we arranged it differently. If instead of doing the 14x first, we did the negative 3x first, then it would have looked like this. And now you're grouping this into two terms, right? Into pairs. So here are our two pairs. And out of the first pair, you can only pull out an x. That's the only thing that they have in common. So we pull out an x, and what we're left with is 2x minus 3. And in the second pair, we could pull out a positive 7. And what we're left with is 2x minus 3 again. And what you see here is that now we could pull out the 2x minus 3. That leaves us with an x plus 7. So you get exactly the same thing. It just, this one step looks different, right? When you're doing that factoring, that factor by grouping, it looks a little bit different. Okay. So before we do another example, I just want to point out why they need to add to b and multiply to c. So take this one, for example. If we were to redistribute this, okay, when we multiply these, everything in the first set of parentheses gets multiplied by everything in the second. So we would do an x times x. That's what gives us the x squared. Look at what gives us the b. Negative 7 times x. Okay, this is what gives us the b. The negative 7 times x and the 3x. That gives us the b. So we're adding these to get the negative 4. This gives us the b with this. And then how do we get the c? Well, we get the c by multiplying those last two numbers. So doing negative 7 times 3 is what gives us that very last value. Okay, so notice the negative 7 times 3 doesn't have any x's in front of it. That's what gives us the c. Whereas negative 7x plus 3x is what gives us this negative 4x here. Okay? Okay, let's go back and do another example with and a that's greater than 1. So we'll do just a few of these. Let's do 3x squared plus 13x plus 4. Okay. So I'm going to put this in black just so that it's consistent and I can use different colors. I'm just rewriting exactly what was there. So our A, and I'm going to do 4 more examples. At some point, you should stop and try it on your own, okay? So A is equal to 3 here, B is equal to 13, and C is equal to 4. So what we need to do first is we need to multiply our A times C. That's 3 times 4. That gives us 12. So we need 2 numbers that multiply to 12 and that add to our B, which is 13. Okay, multiply to 12 and add to 13. So this is like our part 1. This is our part 2. Sorry, part 1, part 2, and part 3 from the instructions, right? Identify A, B, and C, we did that. We multiplied A times C. Now we're up to this step where we multiply to get AC and we add to get B. So we're going to look at the factors of 12. And again, you don't have to always write these. Factors of 12 are 1 and 12, 2 and 6, and 3 and 4. 1 and 12 don't, 2 and 6 and 3 and 4 don't give you 13, but 1 and 12 does. Now our C is positive, so both of the signs, we haven't actually come across this yet, but both signs have to be the same here because B is positive. A times C is positive. Now B is positive, that tells us what sign it is. So it's positive 1 and positive 12. Okay, so what does this mean? Now what we do, and don't forget this part because this is the part that I can see forgetting that, hey, A is not equal to 1. Now we do that part 4 where we replace the BX with these numbers here. Remember, order doesn't matter. So we're going to replace the 13x with an x and a 12x. And now we can do factor by grouping. This is our last part. So we group this into 2 pairs. We have 3x squared and x, and 12x and 4. And we're going to take out something that they both have in common, that both terms in that pair have in common. So the only thing that 3x squared and x have in common is an x. And what are we left with? 3x plus 1. The second one, the only thing that they have in common is a 4. So if we pull out a 4, we get 3x plus 1. Notice that these are the same. Again, if they're not the same, you did something wrong. You didn't pull out something correctly. So we could take out the 3x plus 1, and the only thing left is an x plus 4. So the x comes from here, the 4 comes from here. Set this equal to 0 to find the roots. So this is the same. We're using the 0 property to say 3x plus 1 equals 0. X plus 4 is equal to 0. I'm not going to go through and solve these in the interest of time. I'm just going to write down our answers. So our roots are x equals negative 1/3. You would subtract the 1 from both sides and divide by 3. And negative 4, you subtract 4 from both sides. Those are our roots there. Let's take the next one. The next one is 4x squared minus 16x minus 9. Okay, so again, our A is 4, our B is negative 16, and our C is negative 9. So the first thing that we do is we multiply A times C. That gives us negative 36. So we need two numbers that multiply to negative 36. That's our first step, our step 3 really. Multiply to negative 36, and they have to add to negative 16. Okay, so we go to the factors of negative 36. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Okay, so again, there are a lot of factors here, but only one of them will give us a 16. That's the 2 and the 18. We need a negative 16, so that means that we need a negative 18 and a positive 2. So what do we do from here? We replace the b times x. We get 4x squared. Again, order doesn't matter. We'll put the negative 18x first, plus 2x minus 9. So notice these things are the same, right? We get, when we combine like terms, we get the negative 16x. Okay? Okay. So now we group these. We group it into terms. We have into pairs. We have 4x squared minus 18x, and then we have 2x minus 9. From the 4x squared minus 18x, we can pull out a 2x. And we're left with a 2x minus 9. From the second one, notice we can't pull out anything. If you can't pull out anything, then just stick a 1 in. So it becomes 1 times 2x minus 9. Okay, nothing can get pulled out. So now we just take out the 2x minus 9. In front of the first one, I see a 2x. And in front of the second one, I see a 1. Set A equal to 0. We have 2x minus 9 equals 0. Or 2x plus 1 equals 0. So again, to save time, I'm not actually going to go through the process of solving those. We would add 9 to both sides. Then we would divide both sides by 2. So we get that x is equal to 9 over 2. On the other one, we subtract 1 from both sides, then divide by 2, and we get negative 1/2. Don't forget, if these can be simplified, if they can be reduced, reduce them. If you can't reduce them, leave them. Okay? Okay, let's do another one. 2 more. You should be starting to try this on your own. So, next one, 4x squared plus 17x minus 42. Sorry, some things just appeared. Okay, so identify your A, B, and C. A is 4, B is 17, C is negative 42. Okay, so we multiply A times C. So this is a good one because our A times C is so large. So when we multiply A times C, we get negative 168. This means we need two numbers that multiply to negative 168. This is going to be fun. And two numbers that add to 17. Okay. Okay. So this is not that pleasant because we have negative 168. Sorry, guys. Brute force. There is no shortcut. You just have to know. What you could do is each time that you look at a pair, you say, okay, there's no way that it could be 17. Okay, so for example, we look at 1 and 68 at 1 and 168. You don't have to write that down. There's no way that it could be that you could get a 17 from there. Take 168, just again, brute force, divide by 2, you get 2 and 84. You can see if they're divisible by 3. If 168 is divisible by 3, it is not divisible by 3. I mean, it is. You get 3 and 56. See if it's divisible by 4. It is. You get 4 and 42. Okay. So far, none of these are going to give you 17, so we have to keep going. It is not divisible by 5. It is divisible by 6, 6 and 28. So if you want to save yourself some time, as soon as there's any sort of question, then I would stop and I would say, okay, well, it is 6 and 28. Can it give us a 17? And it can't, so we have to keep going. So this is divisible by 7 as well, 7 and 24. And again, before you keep going, because there are probably more factors, you're going to cross out as you go. You're going to say, nope, that doesn't work. And then you're going to say, wait, does 7 and 24 give us 17? And it does. Okay. If we take positive 24 and negative 7, we get positive 17. But there is no shortcut for this. You just have to do it. Okay. You have to do it like this. So knowing your number facts, seeing that, oh, this might give us a 17, stopping, that will make it much faster. But essentially, you're on your calculator, you're doing 168 divided by 2, see if you get an integer. 168 divided by 3, see if you get an integer, and keep going until you find one that works. Okay? So now, we're going to rewrite this. We have x squared, 4x squared. Plus 24x minus 7x minus 42. Group it. 4x squared plus 24x and negative 7x minus 42. From the first one, we could pull out a 4x. When we pull out a 4x, we get an x plus 6. From the second one, we could pull out a negative 7. So if you see a minus here, pull out a negative. Okay. If we pull out a negative 7, then we get an x plus 6. That gives us x plus 6. And then from the first one, we're left with a 4x. And from the second one, we're left with a negative 7. Set it equal to 0. X plus 6 is 0, or 4x minus 7 is 0. So our roots, first one is just x equals negative 6. The second one, you add 7 to both sides and then divide by 4. So it's 7 over 4. That can't be reduced, so you just leave it. Okay, last one. If you've gotten this by now, just fast forward to the end of the video, okay? We're just fast forward until you see quadratic formula. So this one, 10x squared minus 13x minus 3. So again, identify your A as 10, your B is negative 13, and your C is negative 3. Your A times your C. This is 10 times negative 3, or negative 30. So we need two numbers that multiply to negative 30. This is a little bit easier. There aren't quite as many factors as 168. And they have to add to negative 13. So we go and we look at the factors of negative 30. And again, some of you are just going to see it right away what the two factors are, so you don't have to do this. But just in case you don't, you have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And 3 and 10 is the one that's going to give you a 13. Okay. So this is negative. Our b is also negative. So we need a negative 10 and a positive 3. Okay. That means 10x squared minus 10x plus 3x. Again, if you did it in a different order, you can still get the same answer. It's just that this step looks a little bit different. You're doing it the same way, but it looks different on the paper. So we have 10x squared minus 10x and 3x minus 3. So we factor out our common terms. 10x squared minus 10x has a 10 in common and an x. So we pull out a 10x. We are left, actually, I just want to make sure I did this right. Hang on. Looks like it. We are left with an x minus 1. And then we could pull out a 3, and we're left with an x minus 1 again. Okay. That means we have x minus 1 that we could pull out, and then we have a 10x minus 10x plus 3 that we could pull out. And so we set a equal to 0. We get x minus 1 is equal to 0. And 10x plus 3 is equal to 0. That gives us roots of x equal 1 and x equal negative 3 over 10. No, I made a mistake through the whole thing. Okay, this is good. I know it's going to make this a couple of minutes longer, but it's good for you to see the mistake, okay? So the mistake is I jumped and I said 3 and 10. And I said negative 10 and 3 gives us negative 30. That's true, but negative 10 and 3 does not give us negative 13. So I messed up. Okay, negative 10 and negative 3 would give us negative 13, but this is a negative 30, so both of them can't be negative. So I have to go back and fix this, okay? So I will, and what I'm going to do is I'm actually, just because I made this mistake, I'm going to put X's through everything I made a mistake about. No, I won't. I'll erase it. That's my mistake, okay? So this factors, but it does not give us negative 10x plus 3x gives us negative 7x. Okay, so let's go back and change this because it's incorrect. The one that's actually correct is not 3 and 10. It's 2 and 15. So I apologize for that. I know these videos are long, so every extra step can be a little annoying. So we have 3 and 10, so it's actually 2 and 15. So we would get a negative 15 and a positive 2. Okay, that's what we actually get. So we're going to do this quickly. I'm going to put it on this side of the page. We have 10x squared minus 15x plus 2x minus 3. So this is a really good example of falling into a trap, so be careful, okay? It could happen to anybody. So again, we group our terms, 10x squared and 15x are grouped. Then 2x minus 3 is grouped. From the 10x squared minus 15x, we can pull a 5x. And we are left with 2x minus 3. Plus, can't pull anything from 2x minus 3, so we just have a 1. Times 2x minus 3. So we pull out the 2x minus 3. We're left with a 5x from the first one and a 1 from the second. Set it equal to 0. Either 2x minus 3 equals 0 or 5x plus 1 equals 0. So x, our roots, are x equals 3 halves and x equals negative 1 over 5. Okay, just a little bit longer. This is to solve by factoring. The problem is that this could be very quick, okay, especially if you're really good at figuring out your factors. But not every quadratic is factorable. Which means that you can't solve it this way then. Okay? In other words, if you can't find two numbers that multiply to c or multiply to a times c and add to b, then it's not factorable. So you can't solve it that way. Okay? So these are called prime quadratics. Which is not surprising because if a number has no factors other than one in itself, then we call it prime. So we need to have another way. So another way to find the roots is the quadratic formula. So I'm going to give it to you, but later I'll show you how it's actually derived. You just don't have enough information for that yet. So to find the roots is to use the quadratic formula. And this is essentially a plug and chug. So the quadratic formula is x equals negative b plus or minus, because we could have up to two roots, right? So you're either adding or you're subtracting. That's what gives you your two roots. The square root of your b squared. Notice these it uses a, b, and c from your quadratic. Minus 4ac. And then this whole thing is over 2 times a. And then you just plug in. So let's just take a couple of these. We're not going to do a lot of these because it's a plug and chug. And there's no difference between what you do if a is equal to 1 or if a is equal to 1 or a is greater than 1. So let's say that we have 2x squared minus 3x plus 8. Okay, this is not factorable. There are no numbers that multiply to 8 that will give you a negative 3. So you cannot solve this by factoring. Okay, you can solve any quadratic using the quadratic formula. So that's the huge advantage of the quadratic formula. So the first thing that you're going to do is you're going to identify your a, your b, and your c. So a is 2, b is negative 3, c is 8. That's a plug and chug. X equals negative of negative 3 plus or minus the square root of negative 3 squared minus 4 times a times c. And then this whole thing, the entire thing, is over 2 times a. Okay. Do this in tiny steps. So people try and do a lot at once and they get lost. Okay. So I'm going to show you what I would expect from you in terms of the number of steps on your calculators. So negative of -3 is a +3. Then we can do the -3 squared, right? That's 9. And we could do 4 times 2 times 8, which is 64. So we would just do 9 minus 64. So you can do that in one step. And then divide the whole thing by 4. Okay. Then we get 3 plus or minus, take the square root, take the 9 minus 64 next. Okay, so you get the square root of -55. Okay, now at this point, it's just reducing and simplifying. So you have a negative square root. You want to simplify the square root. So we already know that we could pull out an I. And then the question is, can we pull out any perfect squares? But we can't, okay? 55, there's no perfect square that's a factor. So it's 3 plus or minus I times the square root of 55 over 4. There's nothing that all 3 terms have in common. 3 terms, meaning 3, I times the square root of 55 and 4. There's nothing that they have in common. So these are your roots. Okay, and in this case, they're both imaginary roots. Okay, you could have 2 imaginary roots, 2 complex roots. Let's take one more example. Let's take one that is factorable. So we'll take one from earlier. Let's take 4x squared minus 16x minus 9. And we'll use the quadratic formula this time. Okay. So this time A is equal to 4, B is equal to -16, and C is equal to -9. So x equals negative b, so negative of -16, plus or minus the square root of b squared, so the square root of -16 squared, minus 4 times 4, because that's our a, times c, which is -9. And then this whole thing is over 2 times a. So negative of -16 is +16, plus or minus. Then we're going to figure out what 16 squared is. Okay, 16 squared is 256. And then we have -4 times 4 times -9, which gives us a positive 144. So notice we have 2 negatives here, okay? We have the minus, and then we have the negative. So we have minus a negative 144, which gives us the plus 144. And then we divide by 8. So now figure out your square root. So 256 plus 144 gives us 400. And we're dividing by 8. And it turns out that 400 is a perfect square. This is 20. Okay, so in this case, when you have all integers like this, you're not going to leave it like this even after you reduce it, because everything is divisible by 4 there. Here you could leave it like this because there's no reason to write it as separate roots when you can't do any other reducing, right? The 3 and the I root 55 cannot be added together because one is real, one is imaginary. Here we can add these. and subtract. So we're going to say, okay, well, x equals 16 plus 20 over 8. Or x equals 16 minus 20 over 8. So 16 plus 20 is 36 over 8. And we could divide both things by 4, which gives us the 9 over 2. 16 minus 20 is negative 4 over 8. That should be an 8. And when we reduce that, we get negative 1/2. So our roots are x equals 9 over 2 and x equals negative 1 over 2, which is exactly what we found earlier, okay? So when you have imaginary roots, what you're going to do is you're just going to simplify as much as possible. Make sure that you reduce your square roots. So reduce your radical. Then reduce your fraction. So in this case, all we could do with the radical was pull out the I. And our fraction could not be reduced. If you have all whole numbers here, all integers like you have here, okay, then you should actually write it as the two separate roots. Okay. And by the way, if this is a perfect square, like we got here, that's an indication that, yeah, it's factorable. So at this point, you wouldn't go back and factor it, but it does tell you it was factorable. Okay. Okay. So that's it for quadratics and solving them. In the next video, we'll do one more method. I know this one is long, but bear with it. Okay.